Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is inverse of linear function. Okay, finding the inverse of a linear function. The inverse of a linear function is much easier to find as compared to the other kinds of function such as quadratic and rational. The reason is that the domain and range of a linear function naturally span all real numbers unless the domain is restricted. Okay, I'm going to explain you the examples from linear function. Before I go over the examples to illustrate the procedure, I want to show you how the domain and range of a given function and its inverse are related. Here in this function, linear function, domain and range are just swapped. Let me show you. Do you see this image? For the original function, domain is x and range is y. For the inverse function, domain is the y and range is the domain of the original function. So in this image, please consider that the domain of the original function becomes the range of the inverse function. The range of the original function becomes the domain of the inverse function. So it is customary to use the letter x for the domain and y for the range. Okay, the general approach on how to algebraically solve for the inverse is we will be discussing the inverse of different types of functions in the following videos. So in this video, I am going to show the key steps in finding the inverse of a linear function. First, replace f of x by y and switch the roles of x and y. In other words, I can say that interchange x and y in the equation and solve for the y terms of x. Replace y by f inverse of x to get the inverse function. Sometimes it is helpful to use the domain and range of the original function to identify the correct inverse function out of two possibilities. This happens when you get a plus or minus symbol in between the function. Okay. Please go through the key steps in finding the inverse of a linear function. Now I am going to start a set of examples and explain you how to find the inverse of a linear function. Please look at the example. Find the inverse of the linear function f of x equal to 3x minus 5. This function behaves well because the domain and range are both real numbers. This ensures that its inverse must be a function too. Maybe you're familiar with the horizontal line test. I have explained the horizontal line test in one of my previous video. You can refer to that video, which guarantees that it will have an inverse. Because only by checking with the horizontal line test you can check whether the function has an inverse or not. If it fails in the horizontal line test, you can make sure that the function doesn't have an inverse function. When doing a horizontal line test, you should notice that no horizontal line intersects or crosses the graph more than once. Okay, let's come to this example. We are going to use the key steps that we discussed just before as a guide to solve the inverse function. F of x is equal to 3x minus 5. Now replace f of x by y. So this will become 3x minus 5. Let this as y and x as okay. Now I'm going to swap the roles of x and y. I'm just going to change y as x and x as y. So x is equal to 3y minus 5. Now add 5 on both these sides. So I'll get x plus 5 equal to 3y. If I add 5 here, negative 5 and positive 5 gets cancelled out. Now just swap the sides. I'm not doing any calculation, I'm just swapping the sides because I can have y on the left side of the equation. Now divide the entire equation by 3. So you will get y equal to x over 3 plus 5 over 3, or you can just keep it as it is, x plus 5 over 3, 3 as a common denominator. Replace y by f inverse of x. That's it for this example. This is how we find the inverse of a linear function. Hope that was easy. Let me take another example and explain you. Here is the next example. We have negative 2x plus 10. Towards the end part of the solution, I want to make the denominator positive, so it looks good. I did by multiplying both the numerator and denominator by negative 1. Okay, let me show you. First, change f of x as y. So this could be written as negative 2x plus 10. Now change y as x and x as y. We are just swapping. And now let us solve for y. Subtract 10 from both these sides so that you can get rid of 10 from the right side of the equation. Now I am going to divide the entire equation throughout by -2 so that I can get rid of -2 from the y side. I'm just going to swap the sides because I want y on the left side. I'm not doing any calculation, I'm just swapping the sides. A negative sign in the denominator looks somewhat odd, no? So I'm just going to take negative sign as a common factor in both top and bottom row. I mean the numerator, if I take, it will be, so this gets cancelled out, and the top row can be written as, I'm just going to rearrange it. So it is better to keep a positive number initially. So this is the inverse. One final step, replace y by f inverse of x. So I'll get this. Does this make sense to you so far? So it depends on the problem. So these steps I didn't mention in the guideline. I have just used depending upon the solution I get. Since I get a negative number in the denominator, I'm just using these steps and rearranging the answer. Even this step is considered as a correct one. So this is the inverse of this example. Does this make sense to you? Here is the next example. Please look at the question. Some students may consider this as a rational function because the equation contains some rational expression. Please don't be confused by the fractions here. Yes, it has fractions. However, there are no variables in the denominator. Am I right? So, this makes it just a regular linear function. To work out this, I must get rid of the denominator first. So I'll accomplish that by multiplying both the sides of the equation by their least common denominator. We used to find the LCD and multiply that number on both the sides of the equation. Or I just wanted to get rid of that. No, so I'll do that by multiplying both the sides of the equation by LCD. Let me show you the work. As usual, first replace f of x by y. Replace x by y and y by x. Let's now find the LCD of 3 and 6. So what is the least common denominator? Yes, 6. Multiply both the sides of the equation by 6 so that I can get rid of the denominator. So left side would become 6x and this will get cancelled out for 2 times, 1 time. Are you clear till this step? Add 1 on both the sides so that the negative 1 will be shifted to the left side of the equation. Divide both the sides by 14 so that we can isolate y on one side of the equation. So this is the final answer. We have to replace y by f inverse of x. So we can leave this step as it is because this is best for the final answer since the original problem has this format. So as shown on the board, you can write the final answers 2 ways. One with a single denominator and other is decomposed into partial fractions. Both will be considered correct one. Hope you're clear with this example. Okay, now I'm going to take an example and state its domain and range along with the inverse of the linear function. Please look at this example. This is a normal linear function, however, with a restricted domain. The allowable values of x start at x is equal to 2 and go up to positive infinity because the sign is greater than. The range can be determined using its graph. Please remember that range is the set of all y values when the acceptable values of x, I mean the domain, are substituted in the function. Please pay particular attention to how the domain and range are used to determine using its graph. Let me paste its graph on the board. Do you see the graph? Finding the inverse of this function is really easy now, but keep in mind how to correctly describe the domain and range of the inverse function. We have gone over this concept at the beginning. So about the swapping of domain and range, you can refer our previous videos also. First, replace f of x by y. I'm going to show all the steps on the board. Swap the x and y. So we will get x is equal to y plus 1. Subtract 1 from both these sides. So you will get replace y by f inverse of x. I'm just going to swap the sides so that I can keep f inverse of x on the left side of the equation. For the domain, x greater than or equal to 3 and range y greater than or equal to 2. I have found the inverse algebraically and from the graph I have explained the domain and range. Always verify the domain and range of the inverse function using the domain and range of the original. They are just interchanged. Okay. Here is the last example. Please note the function and the limits given -3 to 3. The first step is to plot the function in xy axis. Clearly label the domain and range. Okay, I'll just draw the graph on the board. Open circle, I mean the unshaded dot means that the number at that point is excluded. If you need, you can check for the my previous video on closed and open. Secondly, find the inverse algebraically as we generally used to do following the guidelines. Okay, make sure that you write the correct domain and range of the inverse function. The x variable in the original equation has the coefficient of -1. Am I right? So please keep track of this as you have to solve for inverse, because the signs are very important here. Okay, now let me show you the steps algebraically. Replace f of x as y. Then replace y as x. I'm just going to substitute. I'm just going to swap it. All x by y and y by x. Subtract 1 from both these sides. So you will get -y. Divide both these sides of the equation by -1. So you will get y x minus y divided by -1. As we generally don't allow a negative denominator, you can just take the negative sign as a common factor outside in the top row. So the signs will get changed. 1 minus x divided by 1 is 1 minus x itself. Okay. Replace y by f inverse of x. So this is the range and domain for the original function. As I said you in the starting of the video, domain and range will be interchanged for the original and inverse function. So for the inverse function, the domain and range would be. That's it for this example. I hope that you gained some basic ideas how to find the inverse of a linear function now. Okay, in our following videos we will be discussing how to find the inverses of other types of function one by one. In case if you have any query, you can let me know. Hope you are clear with the concept that we discussed in today's video. See you in the next video. Have a great time.